Hello, and thank you for joining us today. My name is Katie Yoder. I'm a member of the technical support team at Golden Software, and I'm here today to review how Grapher can be used to visualize your water chemistry data using 3 common graph types. The 3 graph types we'll be working with today are the Piper plot, Derived plot, and Stiff plot. Specifically, we'll be reviewing processing and organizing your data for graph creation, how to create a Piper plot and add customizations for clear analysis, how to create a Derived plot, and how to create a Stiff plot and add professional customizations. After the discussion of each topic, I will have time for 1 or 2 questions. You can send your questions to the webinar host via the questions box on the webinar control panel. Type in your question and it will be sent to me, or to the webinar host who will send it to me. Please send in your questions, but if I don't get to them, I will follow up with an email after the webinar is completed. This webinar will also be recorded, so after the webinar is finished, the video will be available on our support website at support.goldensoftware.com. Click on Training Videos and Webinars, then click on Grapher Training Videos and Webinar Recordings. From there, you'll be able to see the Grapher webinar Visualizing Water Chemistry Data article. All right, let's get started. The first thing we'll be covering today is how to organize your data prior to graph creation. All 3 of the graph types we'll be working with today require some post-processing of data. Stiff plots require the data to be converted to milliequivalents per liter to take into account the valence or ionic charge of each ion. Both Piper and Derived plots require that the chemistry data be converted to percentages so that the relative concentration can be properly visualized. These calculations can be performed in Grapher or in your favorite worksheet program. The first post-processing step for each of these plots is to convert the concentration data for each primary ion found in the sample to milliequivalents per liter using the equation concentration in milligrams per liter times valence over the atomic weight. This conversion accounts for the valence or ionic charge of each primary ion in the sample. As stated earlier, both Piper and Derived diagrams require the data to be normalized to percent of the total ions. The percentage for each ion is calculated relative to the total cations or anions using the equation cation concentration in milliequivalents per liter times 100% divided by the sum of all of the cation concentrations in milliequivalents per liter. Obviously, for anions, you would switch to anion over anion. Now that the data has been converted into the required units, we can begin creating our graphs. Piper plots or trilinear diagrams are used to visualize the relative abundance of common ions in water, rock, or soil samples. One of the benefits of Piper plots is that they can be used to visualize the data from multiple samples at once. Additionally, the samples can be classified in a number of ways, such as to emphasize certain characteristics or identify related samples. By default, Grapher assigns columns A, B, and C as the X, Z, and Y cations, and columns D, E, and F as the X, Y, and Z anions. Piper plots and class Piper plots offer many of the same customization options, so today we're going to create and customize a class Piper plot. To do this, we'll click Home, New Graph, Ternary, Piper class scatterplot. In the Open Worksheets dialog, we'll select a new or open data file and click Open. The plot is created using all of Grapher's defaults, which to begin with looks pretty good. Before we make any customizations, we need to make sure that all of the data columns are assigned correctly. To do this, we'll first click on the cation plot in the Object Manager, and then check the assigned columns in the plot tab of the property manager. Here we can see that the default columns do not match the desired axes, so we'll need to switch the assignments for the Y and Z columns. If we do the same for the anion plot, we'll see that the assigned columns are correct. And if you want to double check that, you can check the ion listed in the object manager for each axis. The first step to making the Piper plot look really professional is to perform some updates to the axis titles. Grapher has the most commonly monitored ions already assigned as the titles, but they need some minor adjustments to use proper formatting. The first axis we'll edit is the anion sulfate axis. So to do this, we'll click on the anion Y SO4 axis in the object manager. In the axis tab of the property manager, we'll click the text editor icon next to the title text field. In the text editor, we'll select the 4 and click the subscript button and then click OK. Now we need to make similar changes to the sodium and potassium, carbonate and bicarbonate, sulfate plus chloride, and calcium plus magnesium axes. As I make these changes, you can see that for the titles that don't need subscripts, I don't actually need to enter the text editor. Now that the axis labels are displaying correctly, let's adjust, the axis titles. Let's adjust the axis labels. The labels should be clear, but right now they pull focus away from the titles and symbols. We can make changes to the labels of all of the axes at once by clicking on the first axis, holding Shift on the keyboard, and then clicking on the last axis. Next, we'll click the Labels tab in the Property Manager and click the plus sign next to Font to expand the section. I'm going to decrease the font size to 12 and change the color to 80% black to match the axis lines. With those changes, you can see that the labels are still clear, but more focus is placed on the titles and displayed data. Next, we can adjust the symbol classes if desired. To do this, I'll click on the cation plot in the Object Manager. Right now, the points are being grouped by a symbol column. Symbol columns are often used in scatter plots and standard Piper plots to assign a desired symbol to a particular point. Since we're creating a class Piper plot, we can classify the points in a number of ways. For example, we could designate the sample collection time, groundwater fascia, or any other criteria that is relevant to the collected data. For this example, we're going to assign classes based on the total dissolved solids count for each sample. To do this, we'll click in the class column field and select column I, which contains that total dissolved solids number. To edit the class symbols and colors, click Edit in the Classes field. In the Edit Classes dialog, we can increase or decrease the number of classes. We can alter data. We could use custom binning to define specific minimum and maximum values to highlight certain threshold values, or we could select Name to use text-based classes. Today we're going to use equal intervals. We can also adjust the symbol size, and colors for each class. These properties can be adjusted for each individual class by double-clicking on the class you want to change, or by using the shared property options below the table. So I'm just going to change the gradient here. And when you're done, you click OK to apply the changes and close the dialog. Finally, we can add a title to the Piper plot and save the finished graph. To do this, we'll click on the graph in the Object Manager, click the Title tab in the Property Manager, and then enter the desired title in the text field here. Are there any questions about Piper plots or processing your data for graph creation? Okay, so I do have one question. Can I add a legend to the Piper plot? Yes, a legend can be added to the Piper plot by clicking on any of the cation, anion, or diamond plots in the Object Manager, and then clicking the Display Legend checkbox in the Plot tab of the Property Manager. For additional information about all of the available customization options for Piper plots, I would recommend checking out our last Grapher webinar, Speed Up Your Workflows Using Grapher 13's New Features, which goes through all of the available properties for our new Piper plot graph type. So another question we have is, do you have to convert to milliequivalents, or could the data be left in milligrams per liter? So Grapher won't discriminate based on the units that the data is in. However, Piper plots are designed to work with relative ion concentrations. That's the way the plot is designed no matter which software package you use. If you don't convert to milliequivalents and then to percents, you're not going to account for or the relative concentration of that ion in the water sample. All right. So next we're going to be covering Derived plots. Similar to Piper plots, Derived plots are also used to illustrate the relative ion concentrations in water, soil, and rock samples. As with Piper plots, data from two ternary plots is projected onto a central third plot. The primary difference between the two is the layout of the three plots. In addition, Derived plots have the ability to display some additional information about each sample. Total dissolved solids and pH are the most common additional information to be displayed. We have not yet added a Derived plot type to Grapher, but we can create one using a simple template available on our website. To do this, we'll click File, Open, select the Derived template file, and click Open. Template files always prompt you to choose your desired data file. So we're going to click our Derived Excel sheet, and then since the same file will be used for each of the plots making up the graph, we can check the Use this worksheet for remaining items box so that we don't have to continue selecting the same worksheet. And we'll click Open. So the settings for the Derived template have already been adjusted to match the Piper plot for the most part. Because the separate plots in this graph are not linked as they are for a Piper plot, editing the settings is a little bit more time-consuming. For example, let's adjust the classes for one plot to match the Piper plot we just created. So we'll click on the ternary class plot 1 in the Object Manager. In the Plot tab of the Property Manager, we'll click in the Class column and assign the total dissolved solids. and click Edit in the Classes field. In the Edit Classes dialog, I'm going to change the number of classes to 4 to match Piper plot, change the method to equal intervals, and change the gradient to rainbow 10. And then click Apply. As you can see, the colors in this ternary diagram changed, but the classes and colors for the remaining plots did not change. So we would need to perform the same steps for each of the plots listed in the Object Manager. The template for creating a Derived plot in Grapher, as well as an example data set with calculations performed, can be found in the articles, Can Grapher Create a Derived Diagram? If so, how? And Grapher is the Geochemist's Toolbox on our support site at support.goldensoftware.com. So finally, we're going to take a look at stiff plots. Stiff plots are also used to display ion concentrations in water, soil, and rock samples. Unlike Piper and Derived diagrams, stiff diagrams do not project this information to determine ionic sample composition, and the ion concentrations are not normalized relative to the total cation or anion concentrations. Instead, the ion concentration is plotted in milliequivalents per liter, with the cations on the left and the anions on the right. The greater the distance from the central zero axis, the greater the ionic concentration. Stiff plots of different samples are often grouped together to highlight differences between them. They can also be used in conjunction with a Piper or Derived plot to highlight samples that may fall outside the normal range or be of interest for another reason. Before we create a stiff plot from our data, you'll notice that the stiff diagram requires that the data be organized a little differently from the Piper and Derived plots. For stiff diagrams, the cation and anion concentrations for each sample must be separated into 2 columns. The ion names should also be included to avoid future confusion and for labeling purposes if desired. To create a stiff diagram, we will click on Home, New Graph, Specialty, Stiff Plot. In the Open Worksheet dialog, we'll select a new or open data file and click Open. And the plot is created. If we want to compare 2 samples, we can add a second stiff plot to the same axes by clicking Graph Tools, Add to Graph, or Plot. And as you noticed, you have to have a plot selected in order for this command to be active. In the Select Plot Type dialog, we'll click Stiff Plot and then click OK. We want to use the same axes, so we'll click OK to the defaults here in the Choose Axes dialog as well. Finally, we'll choose our worksheet and click Open. So as you can see, the same columns that were used to create the original stiff plot are used to create the second one. So we need to adjust these to show the data for the second sample. To do this, we'll click on Stiff Plot 2 in the Object Manager. In the Plot tab of the Property Manager, we'll adjust the left column and right column to show the cations and anions for the second sample. It's still not very clear by default which plot is which because they have the same properties. So we can also adjust the fill and line style for the second stiff plot. To do this, we'll click on the Fill tab in the Property Manager and adjust the foreground color. And then do the same on the Line tab of the Property Manager. Now that we have both of our samples plotted for comparison, we can make some small property changes to complete the graph. For this plot, adjusting the x-axis labels and graph title are some nice finishing touches. So to do this, we'll click on the stiff plot axis in the Object Manager. We'll click the Labels tab in the Property Manager. I'm going to use the same font size and color as we did for the Piper plot and Derived plots, so a size of 12 and 80% black. And then we can add the title by clicking the graph in the Object Manager and entering the title in the text field on the Title tab. Are there any questions about Derived plots or stiff plots in Grapher? So we have one question. Can you add labels to the y-axis? You can add labels to the y-axis, but I actually find it easier if you're trying to label the ions that were being plotted, to add the labels to the plot. To add labels to the axis, you would click on the y-axis and then choose the source for your labels, which may be like your worksheet if you have specific labels defined in your worksheet. To add ion labels to the plots, we would click on the stiff plot, click the Labels tab in the Property Manager, and then choose the appropriate columns for the anions and cations. Because of the way that the labels are added to each ion, you can see that it looks like it's really drawing a line to each of those points for the separate plots. So really you can label the axes either way. Any other questions? All right, so another question we have is, can these plots be used to compare chemistry data over time? Of course, these plots can be used to compare ion concentrations over time. If the samples were collected in the same well over a range of time, we would simply have times instead of location names in the file here as the ID, and then you could apply a gradient similar to what we did for total dissolved solids across the time for each. All right, well, this concludes the presentation portion of this webinar. As you've seen, Grapher makes it easy to create presentation quality graphs of your water chemistry data using a number of different graph types. In addition, the improved default settings and new Piper plot introduced in Grapher 13 have sped up graph creation and improved the initial look of all plots. If you have any additional questions about today's webinar, please email me at katie@goldensoftware.com or check out our resources on support.goldensoftware.com. Thank you for your time and enjoy the rest of your day.